Hello and welcome back again to the workshop. The day before yesterday I uploaded my first video about the shaper or metal shaping machine, and I'm really not satisfied with how it turned out. So I had some trouble with the camera, with the focusing, and I didn't realize that the camera I'm using only works best if you focus manually. And also, without a tripod, the entire video just was wiggling around and was all over the place. So I was thinking about reshooting the video and uploading a remake. And actually I was halfway through the process when I realized, or actually I was all the way up to finishing, when I realized that no matter how sharp I made the knife and how well I ground the cutting geometry, I just would not get the kind of finish that a shaper can produce. And so I was like, well, if it's worth doing right, and if it's worth making a video about, it's worth seeing or worth showing in the video what the machine can do, because that's really what it's about. Anyway, so I realized that for too long this shaper had not been cleaned and not been set up correctly, and basically I got it. It was sitting in my garage for a while because I didn't have a workshop big enough to put it in, and yeah, really I didn't treat it the way it should be treated. And for I don't use it a lot, and I certainly did not use it for making something really precise with a high quality finish yet. I just didn't bother with setting it up right and cleaning it. So I thought, well, if I'm making this remake of the first video, I might as well just fix the machine first and take it apart, give it a good clean, oil everything up, and basically set it up right. To show what it really can do. And then I realized, you see, it's already half taken apart, so I already took off the vise and loosened all those bolts so that I can move everything around freely, and detached the part of the copying mechanism. And then I suddenly realized, wait a second, that might actually be interesting, probably even more interesting than videos about shaping, because there are plenty of good videos out there about shaping and shapers, and really it's just one thing that I started with. I could just as well have started with anything completely different. But maybe the taking apart, cleaning and fixing and setting it up process is a lot more interesting than the actual shaping process. So yeah, I thought I'll bring you in on that. And first thing, or the reason why the really eminent reason was that this block that basically holds the vise and the workpiece had some way in this fashion, or in this axis. So basically what happened is you have adjustable ways all over the machine, and while I had adjusted the ways of the sled, I never did so for the I don't know, for the big block. I'm sure some machinist out there knows the name. I know it in German, but I have no clue about it in English. So anyway, there is a way to adjust. I never needed to adjust. I checked the ways for the up-down axis, but the way that makes the Kreuzblock, this lump, move side to side, those ways just were not tight anymore. So and basically it's just a matter of adjusting it. And obviously if those ways are not tight, then with every push of the machine you will push down this end, and really the workpiece is not held as securely and as firmly as it should be, and that opens up the whole range of problems, starting with vibration to obviously a non-parallel surface between the vise and the surface you're machining. And yeah, basically it's a no-go. It must not happen, and yet it did happen, and now I'm going to correct it. I'll bring you in a little closer and show you where the adjustment screws are and how to adjust them properly. They're now at the bottom of the machine of what I'm for now going to call the support. Probably it's not the proper term, but it's better than anything else I can think of. And these screws right here, they adjust the way. So I loosen them up. Now there is a lot more play in the support than there was when I was machining. I'm going to show this to you. But just grabbing it here and moving it up and down, you can see. Obviously this is not the play in the way itself, but the play in the... it's loose now because I loosened up all those screws. But the important thing is that right down here underneath there is a second set of screws, and these are what we can use to adjust the clearance in the way. Basically, this way over here has a flat surface in the front and half a dovetail in behind. And in here there is again the opposite part of this dovetail that basically goes in from behind, and with those screws on the bottom here you can move this up and down, thereby pushing the other half of the dovetail in this recess and reducing or eliminating all the way or all the give that the way has. Obviously it's important to not clamp it all tight, because that would increase the wear on the ways, and it also would make it harder for the machine to force feed the support, and yeah, that just would not generally not be a good thing. So you want it tight, but not overly tight. You want it just tight enough so that there is no play that you can feel in the support or in the carriage of the support. Okay, now here you can see a close-up of the bottom way. This is the sled, or this is the support block. Here we have the way, and these are the holes for the screws I was just talking about. So I've taken them all out to check and verify the condition of the guide block, or the sliding block here. And I thought I'll just show you the screws that go in here from the bottom. I just have a stud of an Allen wrench, and I can show you when I push up here, like the screw would do if it's screwed in, this block, this slider goes up, and the clearance in between here is reduced. Obviously, at the same time as this block is pushed up, the screws from in front here, I'm manipulating now, they hold this block close here. So basically you loosen them, then you adjust, you push in, you screw in the ones from the bottom so that it gets pushed up, and then you close them. It's very important, excuse me again, it's very important not to loosen those as much as I did, but just a little, just a hair, because as you can see, if I push up here, this block moves not only up but also to the backward position. So if I was to fasten this block in this position now and then tighten these screws, they would push it forward and down again, and I would get way too much pressure on those ways, which would decrease the life of the ways dramatically. Now I'm just going to push this block out from the other side, and we're going to have a look what it looks like. As you can see, it's quite visible where it wore out first and where it is still okay or still good. Over here, let me get a pointer. Over here you have the screws that those four the holes that those four screws go into, and they are the ones that hold this block tight to the support block, or this rail. If somebody knows the term, and I'm sure there will be a ton of people knowing the proper terminology, please let me know. I'd really like to know. Anyway, those 4 screws that are sitting over here hold this block to the support to the cross feed block lump. Also, please tell me the proper term. And those 3 over here go in from underneath, and as you can see, if I can manage not to drop the microphone, I hope you still can hear me. I bet you could hear that. As you can see, these are the 3 spots where those short stubby ones push in from underneath. And now if we take a close look on how this block actually was made, I'm going to bring you in a little closer, hopefully without getting out of focus too much. I think that's pretty okay. As you can see, there are still marks from when this block was made up here, all these, and all the way down here on the bottom. And in between, you can hardly see those marks. That's where it wore off. These marks are from scraping, and you can see they are diagonally. So this way has been scraped once this direction and then once this direction, and again this and this, until you get a really good finish. And yeah, it's still not worn out. It's still okay. I checked it with a hair lineal against the light, which is, by the way, really good way that you can use with very simple tools to really see minute marks of wear and tear. Obviously there is wear, but it's still very well within what I'm willing to accept. And yeah, so that this block sits back here, and this surface, the bottom surface here, rides against the way back here. Okay, so far so good. Problem is, I took a dial indicator and I swept this here, and I have about 1200 millimeter step in here, and then I measured this here, and guess what? It's not 1200, and it's not more than 1200. If it was more, it would be good, because then obviously I could quote unquote clamp these with the screws back on here, but it's less. So obviously this here is already worn in. So now what can I do? Basically the only thing is I can replace this, or I can modify this. So I could take of this surface up here that sits against the back of the table, I could grind off, plane off, mill off a few thousands, or a few hundreds rather, and then I would be nice and tight again. And that actually would be the perfect job for a planer. Unfortunately, mine is out of commission right now, because I have a little problem with the ways there. So I'm thinking, what can I do? And basically what I will do is I will take this over to the mill, and off camera mill this surface with a high grade end mill. Try to get this surface as perfectly flat again as I can. And obviously it's really important to keep this surface, basically to keep the gap between here and here even. And at the same time I have to maintain a pretty much perfect surface finish. So there are two choices, or two ways I can do this. Either I leave the surface down here that's already nice and fit to the way, or and basically just mill off the top part, or I can basically restore this to perfect, take one fine cut over the entire thing and have it really nice. But then if I screw up with the surface finish, I'm screwed. What can I do? I can hone it. So I have not yet decided what I'm going to do. I'm gonna put it in the vise and take one fine pass over here just to see what kind of finish I can achieve. and from there on I'll decide whether or not I'm going to take it all down to flush and hone it, and maybe even have to put a little shim in here to distance it properly, or if I leave the bottom surface and just take a really light grazing pass on the top surface and get that plane. So hello, so now we're back. I've reassembled the machine. All the clearances, all the tolerances in the ways are set to what they're supposed to be. I have put in a piece of scrap material here in the vise, and a general purpose / roughing cutter cutting bit in the tool holder. And I say, let's get off this mill scale and see what kind of finish we can achieve. I'm going to feed in 1 millimeter, 1.5 millimeters, and I'm going to start with wait a second. Whoops. Excuse me. And I'm going to start with 90 cuts per minute. I'm gonna make a test cut with 30 just to see if everything works. Yes, it's fine. To be frank, I already knew that because I already turned the handle once. Now I'm going to increase the speed to 90 cuts per minute, which is about as fast as I'm willing to go, because if you go even faster, then the entire machine starts to jump around on you. And yeah, we're taking our chips. The surface quality is nice, not perfect, obviously, with a rougher, but nice. I'm going to increase the feed. We'll take a little more forceful chips. I think that's too much. Oh, here she sounds about happy. Yes, sir. That's what a properly maintained cutter looks like. And all in all, it took about 3 hours of work, including the milling and the cleaning and scraping some of the ways, and getting all the old sud and sieve out. And now she's up and running again. Now here we are taking a finishing pass, obviously over another workpiece. While recording the last workpiece or the last scene of the video, I was called away to a client, so I had to reshoot the scene and chose to take a workpiece that I actually need for a project. So you can see the finish quality. I'm just going to stop it real quick and zoom in so that you can see a little closer. So you can see the finishing quality is really, really nice. In this direction I can feel some minor surface disturbances. In this direction it feels really like a ground surface. And yeah, so you can see you can achieve actually a really high finishing quality. Also, if you look at the chips, you can see those chips are really fine chips. Here you can see how the chip forms. It's a continuous chip that when working with a shaper is really no problem, because obviously there cannot be a too long chip because the workpiece ends and then the chip is going to end, so you cannot really end up with a big pile of chips that's all piled up and being dangerous like you would on a lathe. I hope you enjoyed the video, and I hope to see you again. So long, and have fun in the workshop.